it's like a theory that a lot of people believe, including people like Elon Musk and all, that we are a part of a simulation. Now, when I say a simulation, it's basically saying that, there is an extraterrestrial being somewhere in the universe, and he's, probably holding a joystick in their hands and playing a video game, and we are just characters of the video game. Like you mentioned, of course, Madhvacharya says that all of this is real, but what is your view on it? Like, do you really think we are in a simulation?
It is true that we do not have free will. Look at Bhagavad Gita, it says, Na kartrutvam na karmani lokasya srujati prabhuhu na karma phala samyogam swabhavastu pravartate.
The very need of a conscious being in order to measure something is kind of eliminated now, because like you just explained. Do you think, does this also tie towards an atheistic thought where that's how the whole world is, the world also, since it is illusion, governed by the laws of quantum physics, does not need a conscious being like a god or anyone for it to create or operate. It can just operate in by itself, like how we call Anthapangu Nyaya in Shastra.
Correct.
And I kind of want you to elaborate a little on that as well. Do you think it is kind of, moving towards that? How do I, say for example, I'm a student and you are already aware of the schooling systems that exist right now. The way we learn science, the way we learn whatever. Me being a student of science, or maybe engineering, or I'm still a school going student or a college going student, how do I get initiated into spirituality? First, is spirituality important at that level of your life first? Second, if yes, then what is the initiation process? Like, how do I get into this? How do I become, or how do I aspire to become the next Jayanth Vyasanakere?
It is not necessary that you can derive everything from Vedas.
Hi everybody, welcome to the Yuvatma Podcast. So today we have Professor Jayanth Vyasanakere with us. So
Namaste.
Thank you, sir. Thank you for coming to the Yuvatma Podcast, and a hearty welcome to you. So how are you feeling today?
Great.
Yeah. So, when we started off with the podcast, we planned to have people from different walks of life. And one of the very popular names and very demanded names that came to our list was your name. So finally we have you today, and it is a great feeling to have you on the podcast. So, we want to, kind of start off with your journey, right? So, your childhood, and how did you transition from being Pujya Vyasanakere Prabhanjanacharya's son and getting inclined towards physics, and your journey from a Acharya's son to a physics professor. So it would be great if you can let us know a little more about it.
Yeah, that's a good question. First of all, there was no transition or a crossover per se. I'm developing in both walks of life. And I would say I'm a student and continue to be a student. And what actually helped me to kind of balance out both was, I was very fortunate to be introduced to the works of Sri Jayatirtha from my father. So Jayatirtha has a very unique style of building an argument. And of course, he also talks about how, what are the different components of an argument, how it has to be structured, what are the different fallacies, what forms an evidence, and what is sufficient, what is necessary.
Oh, okay.
That kind of structure kind of gave me an overview of how to think basically, and that helped me in a big way in all walks of life. In particular, when it came to like logical sciences, particularly physics, it made a big impact.
Okay, great. And I think for the benefit of our viewers as well, can you elaborate a bit on Sri Jayatirtha's works and how logical reasoning is kind of explained or demonstrated in his works?
Correct. Actually, one of the works that any student who wants to pursue rigorous study should look into is Pramana Paddhati of Sri Jayatirtha. It basically, as the title itself suggests, it revolves around what constitutes pramana or evidence. So what are the different kinds of pramana? And when conflict arises between different evidences, how do you weigh them? That kind of approach is, I think, very crucial in not just analyzing scriptures. It's in fact analyzing one's own life. It's really, different kind of priorities arise. What do you prioritize? Of course, one can draw bigger conclusions based on Jayatirtha's works.
That's great. I think, at least amongst Madhva communities, the Sudha Mangala is very popular, and we have heard that that's also one of Sri Jayatirtha's works.
Yes.
And yeah, I think this also gives a very, it's just an initiation to a lot of our viewers to get into this world of spiritual understanding. So yeah, that's great. Thank you for that. So another thing that I would like to understand is, of course, when we speak about logical thinking, logical sciences, right? Of course, there is physics, there is mathematics, and maybe there is applied physics, there is applied mathematics, and all of that. Out of all these fields, why did you choose physics as your major? As all of us know that you're a master's in physics, and you're also a professor of physics. So, what got you into physics? Say, why not mathematics? Why not statistics, or something like that?
Yeah. So, one of the verses in Chandogyopanishad actually says, this is told by Uddalaka to his son Sᴄɪᴇɪ. Yatha ekena jnatena sarvamidam vijnatam syat. What actually is a knowledge is the one, if you know which, you understand not just that one, but a broad class of objects, right? Broad class of phenomena. And that is something that inspired me into physics. Of course, I do respect all branches of science, and of course, mathematics, the one you mentioned, and statistics are so essential parts of physics. But physics per se was interesting to me because it had this kind of aspects highlighted. So I can give few examples. So if you take, for example, light, you can understand light in isolation. Light, what are the different properties of light? What is its speed? Various things. On the other hand, you can understand charges and magnets, and that can tell you everything about light. So this is actually called unification. So you understand charges and magnets, basically electrodynamics, and light falls out as a byproduct. Optics basically falls out as a byproduct of electromagnetism. For example, one can ask, what is the speed of light? How do you measure it? All that is fine. But why does light have so and so speed? Who ordered light to have so and so speed? So that can be understood based on electricity and magnetism. The roots are there, right? Another example is, you see various materials around you. So why are there few objects which are conductors, and why are there few objects which are insulators? And basically, both conductors and insulators at fundamental level are made out of same particles. But one behaves as conducting, another behaves different way. And if you take, let's say, copper, and it is made out of, you say it's made out of copper atoms in particular arrangement and so on. Suppose I give you that this material is made out of copper atoms, so and so describe, so with so and so description. Can you predict that this should be conducting? Can you predict that it should conduct with so and so conductivity? Can you also simultaneously predict that it has to have so and so strength? So all of these kind of get unified. This is what I kind of stated in the beginning as an inspiration. Yatha ekena jnatena sarvamidam vijnatam syat. All of these do not have different explanations. They all come from a common theory.
Okay.
Right? That's the kind of thing that really was fascinating for me in physics. And it also comes with what is called a predictive power. Of course, you can explain what is out there, but what is more remarkable is it also predicts new things. For example, if you take different objects around you, you can predict if I throw something, how much time it takes to go there, based on Newton's laws. But that is not where it stops. The same laws can explain planetary motion as well. And in fact, same Newton's laws were applied on a planet called Uranus, and it more or less captured the movement of Uranus, but there was a small discrepancy. So people postulated a new planet called Neptune, and it has to be of so and so mass, etc., and it has to be found at this point in sky. And when people turned their telescope, there was Neptune. This was around 1846. So a theory becomes more fascinating when it has a predictive power. So,
oh, great. I think so. Physics, in one way, teaches you to question the very roots and causes of nature, and that is one thing. And apart from that, it also gives you a predictive power based on the theories that you develop from as an outcome of those questionings. Right? I mean, that's I think is a fantastic thing that is about physics.
correct.
But do you think the same applies to for example, say for chemistry, say for mathematics?
Correct.
But I think the nature of these predictions and the nature of the things that you understand is kind of different across different sciences.
That's true. That's true.
That's great. I think a lot of our viewers, especially young kids, are physics buffs. As you know, right? A lot of young kids question a lot of these things. So I'm sure this can act as a cue to them to get a bit more deeper into that understanding. So yeah, thank you for that. But there is one question that kind of troubles me, right? Which might be troubling you. I don't know. So on one end we have this logical sciences, which is physics, and on the other hand we have Shastra, right? Because you're like a Sangama, Ganga Yamuna Sangama of both of it. So on one hand you have a faith-based system in Shastra. On the other hand, you have a very logical, sciences-based system in physics or science. Is there a conflict in you that keeps troubling you always? That should I be logical about it or should I be faithful about it? Is there something like that?
Yeah. So I want to say maybe three things about this. Very first one is the two actually addresses two different walks of life. One, Shastras, the more and more you get into it, you realize it is basically about one's way of life. How one should behave in a society, how one should act in a given environment, and how one should realize oneself. That is the basic focus of Shastra. Whereas the focus of science is basically to understand the external world, how it behaves, what are the governing laws, and so on. So they actually address two different things. And then when it comes to faith and logic, this is the second point. So when it comes to the process in which both proceed, in its own domains, are exactly the same. Although the domains are different, the process is the same. That's what I talked about in the very first question. What forms an evidence? What are its fallacies? What look like an evidence but what may not be? And so on. And when there are multiple evidences which may seem contradicting, which one do you hold and which one do you kind of tweak? Yeah. Tweak in the sense that not tweak the evidence, but tweak the interpretation of the evidence, and how do you basically try to give an alternate explanation for the evidence and so on. That process is basically the same. And the third point, when it comes to faith, faith again exists in both places, in both streams that you mentioned. Of course, faith, although everything in Shastras doesn't depend on faith, I agree that faith is an important kind of ingredient in Shastric way of life. On the other hand, faith is also a very, very important ingredient in a scientist's work style, because many students of science, particularly at graduate or undergraduate or even 12th standard students, would be exposed to scientific problems. They will be exposed to problem solving skills, etc. And of course, scientists also solve problems. There is one big difference, which is that students, when a question is given to them, they know for sure that a solution exists. It's okay. That is actually 80% of the effort, and then to figure out, okay, there are established like techniques and you apply them. On the other hand, when a scientist goes about a problem, it's not even clear whether a solution exists and whether the approach is clean or not. And you may be chasing something that is non-existent. So that kind of difference is always there. So you operate based on faith.
That there is something.
There is something, and you're that is the most important ingredient. It can be even a crime investigation by a police officer. It's the same. It's the faith. Okay, it's some kind of gut feeling, some kind of intuition, and it's that intuition which is also there in what, for example, Madhvacharya or Jaitirtha says. That kind of rigor mixed with this intuition, rigor mixed with this faith is.
Oh, but I think, one difference that I personally feel is, like you mentioned, right? So, a student, when he or she gives an exam, is very sure that there is a solution. All the person has to do is to figure out a way to reach to that solution. Whereas when a scientist does it, he or she does not even know that there is a solution. But the very exploratory path that a scientist takes has a lot of, a logical drive to it. Right?
Correct.
So, like say for example, the conductivity example that you gave of the copper, right? So, for a scientist to figure out that copper is conducting or whether it is an insulating material,
Correct.
There is a set of logical steps a person takes and then reaches to that point, right? But does the same happen in Shastras as well?
Exactly. Exactly. For example, you take this particular book. This is Tattva Prakashika of Sri Jaitirtha, which is commentary on Brahma Sutra Bhashya of Sri Madhvacharya. So basically, given a Vakya is a sentence, right? Different words mean different things, and you combine them, you get a holistic meaning, right? But that is not enough. One has to keep it in different. One has to look from different angles. Okay, what is the upakrama, or how did this entire context begin? What is upasamhara? Or where is it going? What is being repeated? What is told with, what is emphasized? And all these kinds of things are, as I said, weighed. And that process of inquiry is exactly, of course, one is dealing with Vakya, or maybe one is examining oneself. Where am I in life? Where am I kind of headed towards? What should I do to, to make the best out of my life? That kind of inquiry, the process of inquiry at a fundamental level is the same.
Okay. So, if I understand it correctly, then like the example that you gave, maybe in Tattva Prakashika, they call it Upakrama, Upasamhara, Phala, Arthavada, Upapatti, etc.
Correct.
But on the other hand, in physics, maybe it's a different step
Correct.
of logical
Correct.
experiments. Great, I think, that kind of makes sense, because a very common view amongst people is that all of this is just faith, right? All of this is just faith, there is no... But this is a very interesting angle that, we should look at it. So, just following up on the same ideology. So, you might have also heard, that ಇದೆಲ್ಲ ನಮ್ಮ ವೇದಗಳಲ್ಲಿ ಎಲ್ಲ ಹೇಳಿಬಿಟ್ಟಿದ್ದಾರೆ, ಇದೆಲ್ಲ ಈ ಸೈನ್ಸ್ ಎಲ್ಲ ಈಗ ಬಂದಿದ್ದು, ಪ್ಲಾನೆಟರಿ ಮೋಷನ್ ಅದ್ರ ಬಗ್ಗೆ ಹೇಳಿದ್ದಾರೆ, ಎಲ್ಲ ಗ್ರಾವಿಟಿ ಬಗ್ಗೆ ಇದೆ, ಎಲ್ಲ ಇದೆ. So what I'm trying to say is, everything that we experience today and everything that we honor as a discovery of science today is kind of believed to be already available in our Shastras in the past. So science has added no value at all. Why should we be so, hyping up science and not the Shastras? So that's a very common, view of people. So what is your take on this? Like, do you think this is right, wrong? What do you say?
No, I think the biggest threat to a dharmic way of life is pseudoscience. And one has to try one's best not to get into it. So, of course, Vedas are, we have not received all the Vedas that were there. What we have received is a small fraction. And even then, there may be different interpretations which we may not be aware of. But with whatever is available, as I said, its focus is different. And the focus of science is different. If for some reason, if you are able to draw some parallels, it's fantastic. But it is not necessary that you can derive everything from Vedas. For example, if there is a new problem that arises, you go with the the same methods that are there in both fields, but you go with the exact manifestations of those methods in that particular field of physics or chemistry to solve that new problem, and not look for a solution in Vedas, right? Because the purpose is different. You are looking at the wrong source for a different problem altogether. And that wherever that mixing can happen, it is at a foundational level in terms of what forms an evidence and what may not form an evidence, and that kind of philosophical level there can be some kind of unity. There is unity. Whereas when it comes to how different processors have evolved and what the outcomes you have got, it's of course addressing two different problems. And mixing has to be done very carefully wherever possible. One is like an acid and let's say another is a base. And when you mix, you better be careful. It can lead to accidents if not done carefully.
Not done carefully. Correct. True, makes sense. So I think what we are aligning on is basically that the evidences and the nature of evidence is the same, but the process in which the exploration happens in two different worlds is different, with a different purpose in it.
Correct.
But when we look at it, it kind of feels that the Shastras have also, they have went out and they have started, they have explored the infinite universe.
Correct.
That's what even science is trying to do.
Correct.
So when both of them are trying to find something which kind of seems like same, is it really right, or is it really the right way to say that, the purposes are different, or is there some convergence in the purpose as well between science and Shastras?
I would say no. There is the purposes are entirely different, because if you look at the nature of the kind of topics that they deal with, in some crude way of saying, one tries to attempt to obtain what are eternal truths, what is sanatana, one which doesn't change, right? One's way of the way in which one approaches one's life at a broad level is not different from what it was some 2000 years ago or some 10,000 years ago. Of course, the different technology would have brought in cosmetic changes. In some broad level, they are cosmetic changes. Yes. But the way in which one approaches life is same throughout. Whereas the science, as we call what is science today, it basically tries to improve what are the different understandings that are there around the world, and it has its own trajectory of evolution. So I would still say that they have a different purpose, they have a different different outcomes as well.
So in the beginning, right, you spoke about Sri Jayatirtha's Grantha, Madhvacharya and all of that. As far as we understand, the Vedic world, the Hinduism, right, Sanatana Dharma, they say that there are different walks of life and all the walks of life lead towards a single goal. So Hinduism is a very pluralistic type of way of life. So out of those multiple ways of lives, so the popular ones are the ones that have directly originated from Vedas, or are mainly concerned with the interpretation of Vedas. Dvaita, Advaita, Vishishtadvaita, and there are many of them. So Madhvacharya, in my opinion, belongs to the Dvaita line. So we would request you to elaborate a bit more on what Madhvacharya, what Dvaita, and why are you so impressed by the works of that line of thought?
Yeah. So regarding Dvaita, there are of course, to discuss these topics, it requires enormous amount of time. So let me try to do best justice I can given the time constraint. So there are 4 tenets of Dvaita which are at the which stand as the center. The first one is about the world itself. The world, the experiences that we have about the world are real. They are not an illusion of someone or ourselves. So there is world, and the experiences that we have are real. So in fact, this also, as you told, comes from Vedas. Satyaso asya mahima, yat chiketa satyamit tan namogham. This is from Rigveda, and even Ishavasya say, Kavir Manishi Paribhu Swayambhuhu Yatha Tathyato Arthan Vyadadhat. Yatha Tathyata is as it is. Vyadadhat Shashvatibhyas Samabhyah. And so on, right? So, this kind of Vishvam Satyam and so on is basically trying to say about the world. This is the Dvaita view of the world. And then, when it comes to the soul, what Madhva actually contributed was about the identity of the soul. And the identity of the soul is something that is eternal. First of all, we have an identity and that it is eternal. This again comes from Upanishad. For example, Brihadaranyaka Upanishad. Avinashi va are ayamatma anuchitti dharma. Anuchitti means it goes away. Right?
Oh, okay.
Anuchitti means doesn't go away. Anuchitti dharma. The basic qualities of a soul remains. So there is a sense of responsibility that brings into us. There is no hit and run. There is no, you hit and then you vanish in blue. It doesn't, you don't kind of, Kannadalli Gumpanal Govinda antaralla, athara. You don't kind of get into a vacuum or you don't get into a bigger object, losing your identity, right? Your identity remains and it remains forever. So this actually brings a lot of responsibility on yourself to act in a correct way, right? And then the third, of course, is about the supremacy of Brahman or the Supreme Being. And in all ways, the one independent entity which controls all other things. That is the other important tenet of Dvaita Siddhanta. And the last one, I would say, is the way in which one can attain the Supreme Being while retaining one's individuality. And this is through a strong bond. That bond is called bhakti, which is, of course, has to be backed up with realization or jnana and service towards the society, which is karma or nana janasya shushrusha, as Madhvacharya elaborates. So these are the four tenets, one starting with the world itself, and then the self,
Soul.
and then the Supreme Being, and what is the connection.
Connection. Oh.
So this is something that you can feel, you can meditate,
Yes.
you can realize, and it's practical.
I think, when I look at we'll definitely expand on the reality of the world part because, we do want to understand it much in depth. But one of the points that, kind of struck me is about the existence of identity and then that being eternal, right? Because these days, when you look at it from a very physical view, you have so many people having a very basic identity crisis, right? But then when you kind of bring this point into them that, you're not just what you think you are, but you are a soul that has existed since time immemorial and you have an identity that is eternal and then you have a responsibility to act correctly like you mentioned. Okay. I think that is not just, that doesn't just have an impact from a spiritual perspective but also a very social and a personal level as well. Okay. So I think this is another way of looking at Madhvacharya's philosophy like you mentioned. So thank you for bringing that view to us. Of course, there are, like you mentioned, it's going to take a lot of time for us if we go on elaborating on Brahman, Karma and all of that, but we surely would want to expand on it maybe in another episode with you. So, but yeah, for now, I think, I have when you're talking about, reality, our experiences and all of that, one of the points that struck me was, these days, it's a very common understanding or, it's like a theory that a lot of people believe, including people like Elon Musk and all that, we are a part of a simulation. Now, when I say a simulation, it's basically saying that, there is an extraterrestrial being somewhere in the universe and is, probably holding a joystick in their hands and playing a video game and we are just characters of the video game. So, like you mentioned, of course, Madhvacharya says that all of this is real. But what is your view on it? Like, do you really think we are in a simulation and whatever we feel is real is not exactly real?
Okay. So, in terms of whether it's a simulation, whether we have free will, etc., it is true that we do not have free will.
Okay.
It is either you look at what Madhvacharya propagated, or the Vedic Vedic kind of way of looking at life. We do not have free will. If you look at
that's a very
look at Bhagavad Gita, it says, "Na kartrutvam na karmani lokasya srujati prabhuhu, na karma phala samyogam swabhavastu pravartate." So therefore there is no question of free will. Whether some extraterrestrial aliens control it or not is science fiction. On the other hand, the supreme being controlling us is what is being said here. And the other part of it is how scientific this is. Of course, in any which way you look at it, we do not have free will. If you look at it from a completely materialistic view, we or our body is basically made out of some set of atoms which are further made out of some set of quarks, leptons, and other set of bosons. And where is free will in this? And these are governed by very specific set of laws. And at some point of time, people thought, okay, there is. I'm sure your people have heard about classical and quantum mechanics. There is, classical mechanics was a very deterministic science, which said, if you tell me where every single particle in this universe is at this point of time, and tell me all their velocities, I can basically predict future.
Okay.
On the other hand, in quantum mechanics, there is some kind of uncertainty, which in some people's view gave an opportunity to bring free will. On the other hand, whatever are those uncertainties are out there and definitely not controlled by our soul. We definitely do not have free will. So that statement remains invariant.
Okay. So then I understand it in a way that the people who talk about simulation and all of that, they come from a angle where there are aliens and maybe a much more smarter civilization than us, and they're controlling us. But I think your view is basically it's not aliens controlling us, but Brahman, the Almighty, that is going to govern us.
The Swatantriya that we think we have is a Brahma or an illusion.
Okay. That I think is a very interesting statement, and I'm sure a lot of us have to spend a lot of time, because
Correct.
Usually, right, say for example, the way what we're doing, right, this whole podcast kind of seems like a few bunch of us together, came together and organized and then all of that. But now thinking of it that, it's not our free will, or maybe we have this illusion of free will in itself is a very interesting concept. And it will take some time for all of us to digest, for sure. So, extending on the same point, so you did mention about quantum mechanics, classical mechanics and quantum mechanics. So, what I want to understand is, from my very limited understanding, and this is the same thing that a lot of our viewers also wanted me to ask you, is that from whatever we understand, right, through social media, through YouTube, etc., that the modern day quantum mechanics, the quantum physics, kind of has a view that, there is no certainty, like you mentioned, there is uncertainty. Every object is there the way it is, just based on how it is being observed, right? So there are different observers who have different realities. So there is no one reality at all. All of it is illusion. The way you perceive the world is how it appears to you, right? That's the common notion, which kind of leans towards the entire world being illusion. Which is again, just like this simulation point, seems like a contradiction to the philosophy of Madhvacharya or Dvaita that you said, that the world is real and the experiences are real. So how do we go about this? I mean, you yourself being, an SME in the field of physics, I would want to understand what is your view on this, and how do you think about it?
So let me spend a few minutes to elaborate what quantum mechanics is all about.
Absolutely, sir.
So in any mechanics, you need two things. One, how you define the state of the system. In classical mechanics, you say there are particles, and each particle position and velocity, let's say, or momentum, define the state of the system. On the other hand, in quantum mechanics, there is something called wave function. right? That wave function is the description of the system. I'm not getting into the technical details, but that is how state is settled. And the second aspect in any mechanics is you have to describe how the state evolves. If you know the state now, can you tell me what will be the state at a later point of time? In classical mechanics, they are given, for example, by Newton's laws. There are different ways in which you can approach it. All of them are being a consistent body. Newton's law is one way of evolving the system. And in quantum mechanics, again, there is something called Schrodinger's equation, which tells you if you know the system now, you can, based on, like what is the environment, I'll put it in quotes, there are more technical aspects around it. Given that, you can say how the state evolves as a function of time. If there is a wave function, what will it be in the next instant? Or it would have kind of changed, it would have changed and so on. So this is about how you describe the state and how the state evolves. Having said this, the next question is, suppose you know the state, what is it that you are going to do with it? So in quantum mechanics, basically, the state or some way in which you can derive out of that state, you should do certain operations on the state that will tell you what is the probability of getting a particular result when you make a measurement. What should be underlined here is, it will not tell you what will be the outcome of a measurement. It will tell you what are the different possible outcomes, first of all, and what are the probabilities associated with obtaining those particular outcomes. That's what the state tells you. Now, what happens when you actually make a measurement? You make a measurement, you get one of these multiple possible answers. And if you do, like lot of times, then you can arrive at what is the probability. Okay, I did some 10 crore number of times, I obtained 1 crore number of times, I obtained this result, 5 crore number of times I obtained this. So accordingly, you can break down what the probability is. So the state is only telling you what the probability of getting a particular outcome. And now, what exactly happened during the measurement? The measurement process itself changes the system.
Okay.
Changes the state of the system. So the state evolves from one. So there is a Schrodinger evolution governed by Schrodinger's equation. That is a smooth evolution. When you poke the system by an instrument, the state collapses to one of the possible eigenstates, which gives you the corresponding outcome.
Okay.
Right? And this is also not very surprising. What is really, because any act of measurement, even in classical mechanics, strictly speaking, when you make a measurement, you disturb the system. Without disturbing the system, without actually, like pressing or punching or do something, you cannot know what is out there. It's not that, you sit here and you get to know the system. Okay. You have to do something to the system you have to probe the system to get something. Okay. Right? Okay. That is not the challenging aspect to digest. What is challenging here is, you just cannot predict what the outcome is. You can only predict the probability. You cannot predict, and the main question that arose here is it our lack of understanding? Maybe in 100 years down the line, somebody will come up with a better theory, which not only predicts the probabilities, but can actually tell you, maybe the description of the state is different in that theory. And that can also tell you what is the exact outcome of the state, outcome of the measurement.
Okay.
Okay. Whether such a theory exists at all or not. That was a big debate. It took almost maybe like 3/4 of a century to settle. Many big shots were involved, including Einstein, Bohr, Bell, aspect, etc. And the point is, at the final outcome of that discussion was, you can show that no such more grander theory exists.
Okay.
Right?
Okay.
So, if such a grander theory exists, it actually contradicts the predictions of quantum mechanics. And you know that actually by experiment. So, this is not something that we can sit and argue, right?
Okay.
Of course, there are things which cannot be tested at all. We can continue arguments forever. On the other hand, this actually became an experimentally verifiable question. That turning this argument into an experimentally verifiable one itself was very nice, and people measured and people made measurements, and the final outcome, as I said, is there is no grander theory or theory which is more grand, which also explains the precise outcome of the measurement. And this is what, that existence of such a complete theory is what in technical jargon is called reality.
Okay.
And that didn't exist. That was the conclusion of all the experiments and arguments. So in that sense, the world is unreal. And what do you mean by unreal? There is no theory that can deterministically tell you what is the outcome of a measurement. That is all about it. The fact that word real was there led to a lot of pseudoscience. Lot of pseudoscience. Oh, the world is unreal. This is what somebody told at some point of time, and that's really unfortunate. So what is to be realized is, of course, you are changing the system by making a measurement, but you are not the one who is creating the system.
Correct.
Right? The system exists, and it's not that there has to be a conscious observer who has to make the measurement. It's not somebody will have to see. It can be a camera. It can be a photographic plate. It can be a pair of magnets actually, which are making the measurement. There is no role of consciousness. So consciousness is also brought into this in some forcible way, right? So which is unfortunate, and that has led to different kind of. So in fact, there are further fantastic experiments though. There is something called delayed choice experiment. There is something called quantum erasure, which are fantastic by themselves, but the bottom line is you can set up all these experiments and then you can actually vanish. The outcomes are outcomes, right? And there is no role of an active conscious being who decides who basically decides what the outcomes are, or whose intervention is deciding how the system behaves. That such a conscious being need not exist in these experiments. Right. You can set up with inanimate cameras and slits and different other objects, and even in kind of delayed choice experiments, or even in case of quantum erasure, there is no role of somebody imagining and creating a system, and all that is bogus.
I think this has a lot of science for all of us. Just to break it down, just so that for all of us understand it correctly. So you spoke about two different fields. One is classical mechanics. Another one is quantum physics. Both of them have something called as a state, right? And both of them have a different state definition. In one place you have, there are multiple, there is a particle which has a space, which has a velocity, and that's how you define a state in classical mechanics. But in quantum mechanics, you have something called as a wave function, and that wave function is your state, correct? The major difference that I understood, from this is that in classical mechanics, there is a clear cause and effect relationship. Correct. You could say that I do this and this is the outcome of that particular activity. Say, for example, I take my phone, I connect a charger, the phone starts getting charged. So there is a cause and effect. But in quantum mechanics, the cause and effect is a little blurry because you cannot predict the outcome, whereas you can only predict the probability of multiple outcomes.
That is what is meant by uncertainty.
Uncertainty. The Schrodinger's equation that you mentioned, is it related to something that?
Schrodinger equation is something that tells you how the state evolves.
Okay, fine.
Uncertainty is our inability to predict what was the precise outcome. Uncertainty also although has a very technical meaning. It's the standard deviation of all the possible outcomes.
Back in school we heard of Heisenberg's uncertainty principle. Is this the same one?
Uncertainty principle, although, is a further step into it. It basically deals with what happens if you try to measure two things simultaneously. You want to measure position and momentum. For example, whatever I told was with a single measurement of, let's say, position. Suppose while doing position measurement, you also want to do momentum measurement. Both of them have uncertainties, and how are those two uncertainties connected? That's what Heisenberg's uncertainty principle tells you.
So that's why the prediction of probabilities is what instead of predicting the outcome is kind of leading into this whole real unreal problem that is there. Correct?
Within quotes.
Yeah, of course, yeah. I know. So I think through when you were explaining, I kind of felt that if we had a professor like you back in school, I think a lot of such answers would be there by now. Luckily, I had a very good physics professor, but yeah, I'm not sure if everyone had. So that was a great thing. But I understand that there is this problem. So there is quantum physics, which is kind of seemingly leaning towards illusion and all of that. But for some reason, there is this hype very recently. Like when I was back in school or in college, there was essentially no such discussion about all of this. But these days, not only the discoveries are happening, but also there is a lot of hype about all of this. Is there any other motivation behind this hype, or is it just scientific? Or
the reason behind this hype can be the following, which is that there is a emergence of popular literature, right?
Okay, can you elaborate a bit on popular literature?
Popular literature is not necessarily technical.
Okay.
So, I'll tell you what is how exactly it kind of becomes popular. So, quantum mechanics, as I tried to simplify, was still looked complex. I don't know. Of course, when you actually look at how to apply quantum mechanics to a so-and-so system, it brings in lot of mathematical, tools as well. One has to be equipped with not just conceptually hard things, but also technically hard things, like mathematics has to be there. Different branches of mathematics has to be at the tips of your fingers to actually apply quantum mechanics to even simple looking systems. Having said this, if you bring in mathematics, then that literature, that book per se, will not be popular. It won't be accessible by popular at a popular level. Therefore, you try to simplify, and you try to kind of narrate quantum mechanics in the language of classical mechanics, which is more understandable and relatable. And technically speaking, it is not possible.
Okay.
But you force that kind of interpretations, and that can actually bring in misinterpretations as well.
Correct, absolutely.
That is the danger associated with popularizing a technical literature, right? And it has to be done with care, and there are only a very few popular looking literature written by experts. And semi-experts, when they actually do this kind of popularization, I cannot guarantee that they would have taken care that things are translated without saying something incorrect.
Correct.
And I cannot also tell you that whether readers read them and basically talk about this, they will try to observe the subtleties and try to appreciate those subtleties. Having said this is first of all a very attractive topic, and when there is popularization involved with some kind of approximation, some kind of simplifications, oversimplifications, it can lead to misinterpretations
and not doing justice to the topic.
Correct.
One side thought that I was having when you were speaking about it is this one of the experiments that you mentioned where the way of measuring can only be maybe a camera that is sitting in front of the system, or maybe a whatever. So the very need of a conscious being in order to measure something is kind of eliminated now, because like you just explained. Do you think, does this also tie towards an atheistic thought where that's how the whole world is, the world also, since it is illusion, governed by the laws of quantum physics, does not need a conscious being like a god or anyone for it to create or operate. It can just operate by itself, like how we call Anthapangu Nyaya in Shastra.
Correct.
And I kind of want you to elaborate a little on that as well. So do you think it is kind of, moving towards that?
No, actually. So, this is again discussed in Brahma Sutra as well. Whether God basically creates the universe and leaves it, and then basically brings in destruction at some other point of time, and in between, if he's not destructing, then of course the world has to run by itself, or whether there is a there is a need for God at every single stage. And Brahma Sutras actually say the need of God is there throughout. And I want to elaborate further on that. Suppose you look at a particle here at the tip of this pen. There is a particle which is governed by some set of laws. If I throw this pen, this is actually governed by some set of laws, right? They are actually basically the same set of laws, by the way. And if you look at some particle in outer space, some particle, let's say on Jupiter there is a particle sitting, and what are the laws governing that? It's the same set of laws. What are the laws that is governing the Jupiter itself? It's the same set of laws. And I don't know at what point of time this particle and the particle that was sitting on Jupiter actually had a conversation and decided that we should obey the same set of laws.
Yes.
Right? It's basically the same set of laws are being obeyed by every single particle, and that's fascinating. That's fascinating, right? And that is where I think these laws are basically established by the Supreme Being. And that is precisely why unconnected objects are obeying the same set of laws. And this is where this is basically the role of God, right? Even apart from creation and destruction, of course creation is not like creating something out of vacuum, and destruction is not something like you push it into vacuum. There is whatever creation and whatever destruction mean, even within that there is something called sthiti. There is not srishti and laya, there is something also called sthiti. This sthiti also has to happen. Now, what did I mean by saying there is no conscious intervention? That was your other part of the question. Correct. When God says, okay, these are the laws I'm going to follow, that's it. There is no further intermediate interventions saying, okay, by the way, for this there is an exception, I'm going to do this. There is no something like this, I'm going to do that. It doesn't kind of disturb the flow in that way, right? The laws are set and then the game is played. And that is the kind of reason why I told there is no conscious intervention needed. Once you set up the system, then there is no further imagination that is required by a particular conscious being, and the result of which is the existence of these objects. That kind of thing definitely is not there. It's not that it is not needed, it is definitely not there. And even for the regular progress of these experiments, a conscious being doesn't have to be there as a human being. I don't have to tweak it at every single point of time. So there are two things here.
Correct.
Now let me try to repeat.
Sure.
One, for its regular evolution, I don't have to tweak it at every single time. The laws are set, and they govern the evolution of the system. And the second is that it's definitely not that I am basically a consciousness, or there is a supreme consciousness which is imagining stuff and it's an illusion, and that's why we see it, which are not there. Of course they are there. Even if I don't imagine, they are there.
Yeah, that's fascinating. The thought that two unconnected particles obey the same set of laws somehow kind of sparks this thought that there has to be one governing power that enforces this pattern, right? So yeah, that's great. So following up on our whole simulation and science fiction theories, another popular understanding or another popular inquisition amongst people is time travel, right? Can you travel in past, future, all of that? And there are some examples of that in our Shastras as well. Say, for example, not travel in past, but travel across different places. So for example, Krishna asked all the grahas because he wanted to do a tapas for 12 days, and he asked the sun to travel around the earth for 12 days, and he just finished his entire tapas in 5 days and all of that. So the point is, this whole time travel is, I explained a little in Shastras as well, and is also a common thing that a lot of people are interested in. So what do you think about it? Do you think time travel is possible? Can we go in past, future, all of that?
Okay. So the time travel, particularly entering science fiction, was after relativity. So what is possible in relativity, I can tell you. Imagine there are two events. So can you say, for example, what is the time ordering of these events? Whether this happened first or this happened first. Event A or event B. Can it depend on the observer, for example? For example, these two events, if observed by a moving observer, can it appear that B happened first and then A happened? For another observer, A happened first and B happened later, or some observer, third observer, both happened simultaneously. So this order can actually, according to relativity, can vary depending on the observer. The time ordering can depend on the observer. So in one frame, A happened before B, and in another frame, B happened before A. However, there is a limitation to how far you can stretch, right? If A can influence B, not influenced B, can influence B. How can it influence? At best, the fastest influence it can do is through sending a light beam. So if the spatial separation is such that if light takes so and so time to travel from one event to the other event, then that is the upper limit of how much you can vary. So you can never change cause-effect relationship. So causality or karya-karana bhava can never be interchanged. So basically what you can, the logic proceeds as follows, which is, if there are influences that can travel faster than light, you can change karya karana bhava, you can change causality. Because you cannot change causality, there is no influence that can travel faster than light.
Okay. So that's the limit, right? That's
Correct.
The upper limit.
That's the upper limit. And that also sets an upper limit on the fastest influence that can travel. And the other aspect that you mentioned, Krishna asking Brihaspati to go once around, in single day, go around all 12 constellations to complete 12 years. Jupiter actually takes 12 years to go around, is like how the clock actually goes up. And that is, I would say, it is not a kind of example of a time travel.
It's not a time travel problem.
It's a different fantastic thing that happened, but not coming into time travel.
Okay, sure, sounds good. So since like how time travel is a very populist theory, so there is another new Netflix show called The Three-Body Problem. So there are two aspects to it. One is the physics of it, and second is the fiction of it. Have you watched Three-Body Problem?
No.
Okay. So let me give you a view of what that show is all about. So three-body problem. So what do they essentially say is there is Earth, and there are a lot of other interplanetary systems. So light years away from Earth, there is another extraterrestrial civilization, which is on a planet that is in a tri-solar system, which means it has like 3 stars. And because of the three-body problem, the civilization, the planet itself is very chaotic. Since the planet is very chaotic, there are no patterns in seasons, there is no patterns in anything, right? Because of the chaos, the civilization has not progressed at all, because every time they try to do something, something else happens, a major event happens, and there is a complete collapse. Because of that, this extraterrestrial civilization now is eyeing on Earth. They want to come back to Earth, either make us slaves or kill all of us and then take over our planet. Of course, spoiler alert, but yeah. So this is what the show is all about. I'm not sure how much of it is fiction, how much of it is reality. So yeah, if you could elaborate on the physics part of it and the fiction part of it, that would be great. Yeah.
Okay, so this is basically fiction. There is no such evidence for any such thing.
Okay.
Having said this, because you mentioned three-body problem, I can tell you a few interesting things about the three-body problem.
Awesome, that's great.
So, if you look at stars, they look like point objects, right? But if you observe them closely, sometimes you see that, okay, this is not a single dot, but there are actually, you can resolve 2 separate dots there, right? For example, there is a star called Sirius or Lubdhaka, Vyadha is also another name.
Oh, okay.
So this is the brightest star in the night sky. But it is not a single star. There are actually Sirius A and Sirius B. It's a binary star system.
Okay.
Just because you see two stars doesn't mean that they are binary, because they can be at two different distances. Only because their angular separation is small, you may think that there are two objects. So you have to establish that they are gravitationally bound. Only then it's a binary.
Binary system. Okay.
Similarly, there are objects which are actually, when you zoom in further, of course the technology enables you to observe closely, resolve different parts of the system. You see that it's not a single object, it's actually two, but not even two, it's actually three. Okay. So a good example of this is Polaris or Dhruva Nakshatra. Dhruva Nakshatra is not a single star. So there is one star, and then there is another star. This is called Polaris A and this is Polaris B. And that there are actually two different stars which are gravitationally bound was established 250 years ago. Okay. And then when later in the last century, when people observed Polaris A itself, they came to know that there are actually Polaris AA and Polaris AB.
Oh.
So there is Polaris B, Polaris AA, Polaris AB. This is a triple star system. So of course mathematically it's a complex problem even in classical mechanics, because first of all you can't write down closed form solutions. You need like numerical methods to analyze a general three body problem. On the other hand, for two body problem, if there are two objects which are going around each other, you can, if you give me the initial position and velocities of both objects, I can tell you precisely what is going to be their life.
Okay.
For the three body problem, such a closed form expression which you can write down on paper doesn't exist. You will have to numerically run and you will have to predict. Of course, that is one aspect. There is also some chaos associated with the three body problem. A small difference in initial conditions can lead to wide difference in the outcomes if you run for some time.
Okay.
So that is about the three body problem.
Okay.
And because we also discussed different aspects of Dvaita, there is something you can look into. Of course, this is an analogy. So at some point this star looked like one object, right? So you look around the world and you think everything is made out of one thing. And then you see that there is actually two, right? You see that there is non-living objects and there is living objects. For example, yourself is a living object. And then you look within yourself more closely and you see that, okay, there is actually two consciousness within myself, and there is Jivatma and there is Paramatma. So that is like AA and AB in some sense.
True. Yeah, I mean that's true. So I mean, one of the things that was kind of shown in the show was that since, like you mentioned, a triple star system, there is a planet which is under the influence of these three stars, the gravitational force of these three stars. Because of that, since the gravitational pull in itself is not symmetric and not deterministic in some sense, it's pretty chaotic. But yeah, I think we got a view of how it is. So yeah, I think we have had a lot of science, and thank you so much for all of this. Now I would want to understand. Say for example, I am a student of science, right? So coming back to your life and your career and the way you progressed. So for any science student, I would want to know what are the major career opportunities these days, because in my view, from whatever I understand, I feel that in the last couple of decades, there have been no major big breakthroughs in the field of science. Like so at one time, we have heard of Newtons and Einsteins and Bohrs and all of these people in the past. But I at least don't hear of any of such big scientists in these days. So what is exactly happening in science, and what are the career opportunities for any student of science?
Okay, I can talk about physics, and what you said is true. In recent times, the field looks kind of saturated, and career opportunities are less if you are a physics student.
Okay.
Having said this, if you are aiming for a dependable job, then definitely physics is not a good avenue at all.
Okay. Okay.
If you are, the word should be underlined, which is if you want a dependable job,
Okay.
right?
Okay.
If you do well, of course, whatever you do will get into a good job, but that's the situation. Having said this, the nature of physics itself, the nature of, like if you look at how it is done, you do physics because you enjoy doing physics, and sometimes there are fame and glory associated to it. Sometimes it so happens that there are practical applications and therefore job opportunities, etc. But the main focus of physics is not towards applying physics per se. At least the names that you mentioned approached physics to basically because they found solving the brain teasers that nature throws at you is a reward in itself.
Oh, true.
That's how a painter paints a painting. It's hard to ask what are the practical applications of this painting.
Correct. Yeah.
Right? It's
just an expression of art, an expression of
art. Similarly, discovering what is Bhagavad Ichha in some sense, or what are the governing laws of this world. Can you make some new predictions? It's a joy in itself. And because we have been discussing spirituality as well, in some sense it kind of connects to nishkama karma. Right? You do so you must have heard karmaṇyevādhikāraste ma phaleshu kadāchana. So you do your work and don't worry about the
outcomes of it.
Outcomes at every single stage. Of course outcomes will come. There are larger outcomes and there are smaller outcomes. One has to have a big focus. It's a separate thing. But if one always worries about the outcome, the action actually gets distorted.
Correct.
So doing physics is primarily done for fun. Of course, there are applications and big applications as well. Of course, if you actually go back to some 1800 or 1900, physics also had huge applications towards politics, towards even warfare. You can still argue that certain developments in physics, for example, quantum computation, can lead to technology that can also bring in power associated with it.
Okay.
But the progress has been slow.
Correct.
Superconductivity, on the other hand, is another example, which, if realized at room temperature, can make magic. But like as I told, the progress has been slow.
Okay. I mean, I kind of, because my next question was going to be on superconductivity and quantum computation, because in my very limited view, that is what major applications of science are going to be in the next few decades. But yeah, thank you for answering it preemptively. So another thing, another special aspect about you that we all know is, like I mentioned, your scientific expertise on the one hand, on the other hand, your spiritual inclination, your understanding, your objective understanding of the spiritual text and all of that. What I want to get from you is, how do I, say for example, I'm a student and you are already aware of the schooling systems that exist right now, the way we learn science, the way we learn whatever. Me being a student of science or maybe engineering, or I'm still a school going student or a college going student, I may be at any different level, stage of my life. How do I get initiated into spirituality? First, is spirituality important at that level of your life? First. Second, if yes, then what is the initiation process? Like, how do I get into this? How do I become, or how do I aspire to become the next Jayanth Vyasanakere? So what is the way for it?
Okay. So see, this is basically a long-standing question. At every stages of civilization, we had the very similar question, right? So this has been answered. This is a kind of canonical question for which there is a canonical answer. But what has kind of changed, for which I guess that's what you're probing at, is the explosion of technology. While this has brought in, it has basically enabled us to get more access to resources. It has enabled us more freedom as well. It has also brought in so many opportunities to, in some sense, distract us. And what it has taken away from us is time, and meaningful time, right? And the first thing I would like to say is to watch out for how much time we spend on aspects which are not really necessary and which are basically some kind of super luxury, right? If we kind of pay attention to that, we suddenly realize that our lifespan has increased by a huge factor, right? And that's the first realization. And then this is actually coming from Bhagavata. It says entire Shastra are basically trying to say two things. Shastresh viyaneva sunishchito nrunam kshemasya samyak vimrusheshu hetuhu asanga atmam vyatirikta vastuni dridharatira brahmani nirgunechaya. One is asanga. That's the aspect I try to emphasize. Whatever is not really necessary for your own good, one has to have maturity to get rid of them and try to make time. That's the first thing. The second one is dridharatira brahmani nirgunechaya. One can try to establish the bond with the Supreme Being. And how is that possible? So this is where Brahma Sutras come to. As I told, this is a canonical problem for which there are canonical answers which I can borrow. So there is something called Brahma Jignasa. It starts with Athato Brahma Jignasa. Brahma Jignasa is one's Jignasa. Jignasa is to basically one's urge to know, right? And what is really important in this urge is to not give up rigorous study. One has to get into rigorous study. Whatever it is, whether it is science or whether it is adhyatma, whatever study you do a rigorous study. You figure out what is the field like, you figure out what are the resources that are available, get started. And of course, the important thing that one realizes is when is the right time to get started. And the correct answer is yesterday, right? Not even today. So one has to get started. One has to realize what are the different available options, and then try to figure out what best can be done and get into a rigorous study. And then things happen, like as byproducts.
Yeah. I think that's, taking the path of rigorous, first of all, like you mentioned, asanga, that is, detaching yourselves from the super luxurious, items or whatever that you spend time on, and then making time for yourself, and then taking the path of rigorous study to get into this, I think is probably the most sustainable way of getting into spirituality. And, thank you for, bringing light to this. So, I think we have discussed far and wide about a lot of things, but even now I don't think we are done. So there is just so much that we want to know from you. Maybe we'll probably do another episode with you on a different sessions as well. But for today, thank you for making us aware of pseudosciences. Thank you for explaining how quantum mechanics works. Thank you for answering few of our stupid questions, but a little interesting questions as well. So yeah, it was great talking to you, sir, and yeah, we hope to see you again on this podcast with a whole different agenda. So thank you so much again. Yeah.
Namaste.